Let's look at petrol-electric hybrid vehicles. In this module, I want to discuss the issue of dealing with these new hybrid vehicles. Now, hybrid vehicles make use of both an electric motor and a gasoline engine for vehicle propulsion. Now, electric power is used for low-speed movement and is powered by a high-voltage battery pack located in the rear of the vehicle. And this picture shows you the various elements. As you can see there, that's the system there located there, the hybrid system. As you can see in this picture here, there's your fuel line, your fuel tank. You've got a high-voltage battery cell. Their ones there are the high-voltage cables. So these are high voltage. Be very careful with these. And you've also got 12 voltage batteries here in the engine compartment, the trunk. The main things for worrying for yourself is where it is located to the fuel tank and where the high voltage cables are. Now, in hybrid vehicles, high voltage cables are identified by orange insulation and connections. Now, while you need to be aware of these cables, they are routed generally underneath and inboard the floor pan reinforcement in an area that's not generally accessed by rescue personnel. So generally you should not be gaining access to it, but in a full vehicle crash they may be exposed. It's important to note that hybrid vehicles, which may appear to be inactive when the gasoline engine is not running, may still be in the ready state and capable of motion at any time. To prevent this from happening, in addition to disconnecting the 12-volt battery, rescue personnel should also check to make sure the main ignition switch is turned to the off position and the key is removed, which disables the electric drive system. And remember, never touch, cut or open any high voltage power cable or high voltage component. Be very careful with these type of vehicles. Now I want to discuss vehicle collision kinetics. As you can see here, the kinetics there to cause that damage there are quite significant, and that's what I want to look at. Now, first of all, I'll look at is tension, flexion and torsion. These three areas. These are very important factors that you should be aware of. Now, metal that is bent, this is what we call flexion. Metal that is bent, so it could be stretched, which is tension, or it could be twisted, which is what we call torsion. It requires caution when cutting or spreading, as rapid, unexpected movement may occur. So that's why you need to know these three areas: flexion, tension or torsion. Now, the rescuer must understand the mechanical reactions and the potential reactions in the body of a vehicle that occurs due to the deformations of the car after a collision. Now, when talking of a mechanical reaction, impact during the collision that modifies the structure of the car, that's what we call mechanical reaction, we will speak of stable points and elastic or unstable points. Now, to work effectively, it's often necessary to eliminate the unstable or potentially elastic points in order to avoid an unwanted return of material during the cutting or in spreading. So in other words, take them out. That's the bits you want to remove when you're cutting them. Now I'm going to look at the situation with a frontal collision. As you can see there, a frontal collision. Now, despite the reinforcement of passenger cell areas in modern vehicles, we must realise that crash tests are performed at relatively low speeds. So these tests are performed at low speeds. At higher speeds, much more deformation can occur and it complicates the rescue efforts. This picture here shows you how the passenger compartment is significantly compromised, resulting in the likelihood of more serious injuries, as you can see there. This picture here shows you less passenger compartment deformation results in the likelihood of less serious passenger injuries. What about side impact then? As you can see here, this is a side impact here. Now, side impacts results in high mortality rates as there is little space between the outside of the vehicle and its occupants. So side impact, if something hits you there, you've got nowhere to go. Well, at least a front impact with the crumple zones, it's safer. In most cases, deformation of the passenger cell results in very little space in which to work around the patient. And when possible, concentration of extrication efforts on the undamaged side will often allow for a more effective extrication. So wherever the side that's been damaged, you might want to work in the other area if you can, because you've got more access. These pictures show you the aftermath of a side impact here. What about rollover collisions? Now, in these cases, the most important aspect of a good extrication is proper stabilisation. So when it's a rollover collision, the key thing you've got to remember is stabilising that vehicle, because it's not on its wheels, it's not stable, it's not got any stability. Extrication may be further complicated if the occupants of the car are lying in awkward positions or suspended from the restraint devices, so they might be hanging from the seatbelt. So these are really, really tricky to deal with. It's particularly important in this type of crash that movement of the patient is minimised. So don't start on doing the seatbelt and the person collapsed. Make sure the medical services are there first, telling you, basically looking after the patient and making sure you know what to do. This shows you the aftermath here of a rollover collision. Look at that. Survival rates, very low, very low. Yeah, there's a fire service dealing with the incident. Now let's look at underrun and crush accidents. Here's a few pictures there, look at that. That's an underrun incident there. And there's another one, an underrun where it's actually gone underneath the vehicle. With these accidents, as you can see here, you're working in confined working spaces, and in many cases complicated entrapment makes these types of incidents very difficult to handle. Yeah, because you're underneath the vehicle, it's very hard to deal with these. And it should be remembered that good stabilisation of the crushing load is paramount, and that heavy lifting operations may need to be performed. So heavy lifting. Now, rescue activities may affect the stabilisation. For this reason, stabilisation must be continually monitored as the extrication progresses. So it's not just when you get there you make it stable. When you do any lifting or movement, always consider your stabilisation. And shoring devices may enhance these efforts, the stabilising efforts.